Hello everyone, welcome back to MAT052. Hope you're having a good day. So this time we're gonna talk about translating between symbolic notation and words for hypothesis test. Don't worry about this 6.3, it's not really corresponding to our book. But this is a new topic away from what we've been doing, confidence intervals. Our next major topic in MAT052 for us, is doing hypothesis testing. So this is a new concept, and basically what we're going to do is try to prove or disprove somebody's statement about one of the population parameters. Be it the population mean, we think the mu is less than 200. We think the population mean is less than 200. Is there something that we can do to test it to be true or false if somebody makes a claim? I know that the population mean is much greater than 120. Is there something that we can do to test the validity of a statement based on some statistical parameter? And there is, it's called hypothesis testing. So what we're going to do is just basically go grab a sample. We may not be able to measure all the population, it may just be too unwieldy. You know, we got millions and millions of people, and that's just too many to go poll for everybody or ask everybody or measure. So what we're going to do is just go grab a sample and then look and see using components of sampling theory that we have done to see, is it reasonable that if we just grabbed a random sample, you know, how it should be very close to what that mean is. And then if it's not, we're basically going to disprove it. Okay, so that's what we're going to do. Is we're going to start out with this hypothesis testing idea, is that we're going to take a statement about the population parameters, the mean or the proportion, and then build some statements and build a test framework. And then we're going to go about and do the test. But we have to build a test framework first. Okay, we just don't go automatically start testing. So we build it, and it basically is a procedure that we're going to have to go through. It's the same thing every time, but it starts with putting the statement that someone is saying or making a claim about into mathematical terms. So here, I think we're missing on here. We've got a statement. So here's a mathematical statement that that the mu is less than 10, and we've kind of looked at these type statements. The mean is less than 10, where mu is the average waiting time. Suppose that a bank advertises that the average time customers wait in line is less than 10 minutes. And for some reason this thing has gotten mixed up, but that's okay. Translating between words and symbolic notation is an important step in hypothesis testing. But let's just kind of go. So we're taking a statement. A bank advertises that the average time customers wait in line is less than 10 minutes. I think, let me fix this for us real quick, so that at least we'll have it here. And it's saying that they make a claim, and then I want to write this symbolically as the mean is less than 10. Okay. So basically we want to have a type of hypothesis test, and let's go through here. There's actually a couple of different versions of it, but it all starts with taking a statement of or a claim about a population parameter. Okay. So basically we're going to take a test, and I'm going to build two statements. So this is kind of jumps out pretty quick. So let's go with here. Let me set something here. So let me put a couple of notes in here to make this maybe a little more understandable. We're going to start with a claim. Let's say claim is that the mean time is less than 10. So I'm going to start out with a statement, and I'm going to kind of make a note claim, but I don't really care about it at this time. It could be anything. And then I'm going to do a second, and I want to call this the complement. It's what's left over. So if this is less than 10, there's also a possibility then that mu could be greater than 10 or equal to 10. Now later on in your book, they're going to say, oh, this is just less than 10 or equal to 10. But when our test, we just want to make sure we write it correctly to start with. But if it fails for the equal, then it's going to fail for all these greater than as well. But trichotomy is either less than, equal to, or greater than. And this, by writing it this way, it captures all of that. So I want to write a claim and then a complement. So those are the two steps. And then I'm going to assign a null hypothesis and an alternate hypothesis. So this is going to be one of the statements and the other one. But the one with the equals, so if it has equals, I'm going to call it the null hypothesis. May or may not be the claim statement. In this case, it's not. Okay, but the other is the alternate hypothesis. Okay, so this is also shown as H sub 0, the hypothesis 0, the null hypothesis. It is the one that has the equality always. So it could have been either one of these, but I'm looking for the equality to assign H0, and the other one is HA or H1, depending on the book or as you go through, okay? So the null hypothesis states that a population parameter is equal to. So that's the one that I'm looking for that has some equal to, but it also takes care of all the other side as well. The alternate does not, okay? The alternate may state that the parameter is less than, greater than, or not equal to. This is less than or equal. Either less than or equal to, but not equal to it. Less than or greater than. Okay, so this would have been this version if this is equal, okay? So in determining hypothesis, we often look for keywords when translating to symbols. The following table presents a list of keywords and a meaning associated with each. So the meaning is less than, fewer, below, shorter, smaller. I'm always going to use that. The mean is below this, is shorter than. The height is shorter than, the average height, okay? Greater than, more than, over, above, exceeds, that's always given by that symbol. So these would be, if I'm just writing, the first step is writing from the claim. So I've got a claim, and I'm kind of breaking this thing down to these four statements and writing them here. If I have an equal to, they're making a claim that this is exactly equal to 120 or something like that. We think that the mean is 120 based on our research, okay? So you would write this down and then you would do an independent test. I would write the complement and then you would go, okay? So if I have this, I'm gonna sneak this complement in here. So if I'm starting, I start with the claim, I write this, and then the complement from that would be greater than or equal to. If somebody says something is greater than, I would say the complement is less than or equal to. If they said this is equal to, the complement is not equal to, and that's the same thing as that. It's either less than or greater than, and we don't know which. It could be based on the sample, and this has a specific meaning as we go along and building a test method. Not equal to, that's fine, that's the very same thing here. The complement would be equal to. Okay, so then I would go back and I would do my assignments of H0, the null hypothesis. Which one would it be? Which one's got the equal? Here, this would be my null hypothesis. Which one has the equal? This one. That would be H0. That would be the alternate. This would be the alternate. Here, which one has the equal? Here. So this would be H0, whether it's the claim or not. Doesn't matter, all I'm looking for is the equal, and then this would be H0, this would be HA, and this would be HA here. So it all depends on the statements that you're building. It could be, the statement could have been greater than or equal to this. That would be your claim, that would be H0, and then the alternate, and it all depends. But that's what you're looking for. And once you do your assignment from the claim, your math assignment, then you're going to do your complement, assign your H0 and HA, The HA is going to be a very specific thing later on that we're going to use for HA. So that's why we need to have that, and it's going to point to us to give us some idea, okay? So let's see what we can do. So the owner of a bakery claims that the mean amount spent by customers is more than $15. State appropriate and appropriate null and alternate hypothesis. So first of all, this is, okay, so I'm going to go over here and I'm just going to do my little version of it, and then we'll do the textbook. This is, there's like a 50-50 textbook on how you write this, but I like the math version better, and I'll tell you why. So I'm going to have a claim. Let's write the claim first. The owner of a bakery claims that the mean amount spent by cover is more. So all customers is more than $15. At least $15 would include the 15, right? It would be greater than or equal. So then I need a complement. Mu less than or equal to 15. My next step was assign H0 and HA. So my H0 would be the one with the equals right here. That mu is less than or equal. And in this case, they're just writing it here. But I like to do this just to keep, because there is a difference between less than or equal to the way we do the test than equal to. But if it fails this, it fails all the less than as well. But this kind of keeps us in track that there's going to be a difference between mu is equal and then the not equal, which is the 2 version later on. And then our HA would be the one that doesn't, mu greater than 15, okay? But again, your book likes this format that mu is equal to 15, and this, if it fails for this, it's going to fail for all of them. But again, I like to do trichotomy. There's really 3 situations that it could be. It could be less than, equal to, or greater than, and that the way you write it here takes care of everything, and you're not kind of saying, well, what happened to the rest of them? But this works as well. So in Alex, you'll have equal to versus this, but this is the way that I kind of I go about it. Okay, so here's an example 2. In a random sample of 1,627 cars, 97 of them exceeded emission standards. An environmental specialist wants to test whether less than 5% of cars exceeded emission standards. State an appropriate null and an alternate hypothesis. He wants to test whether less than. So he wants to know that the population proportion P is less than 0.05, the 5%. Okay, so this is our claim or our test that we want to do. I want to complement P greater than 0.05, greater than or equal to, less than, greater than or equal to, and then I go and assign H0, HA. This with the equals would be my H0. This would be my alternate, the other one without the equals, okay? And that's where you're getting here. And again, in Alex, they're going to say which, do this is the piece that they like doing it as well. But this is really saying that you're testing for that. You're testing for greater than or equal to versus less than. Okay, but when it fails this, it's going to fail all the other ones in there as well. So at a certain college, it took an average of 5.2 days to process admissions applications last year. New policies have been put in place, and an administrator believes that the average time is now different from 5.2 days. State an appropriate null and alternate hypothesis. So he wants, this is his claim or his hypothesis he wants to do, that the average time mu is no longer 5.2 days, no longer equal to this. So now what is our complement? It is mu is equal to 5.2, okay? H0 goes with the equalities. HA goes here. And this not equal to is the very same thing as that. It's either could be less than or bigger than. It's just not equal to 5.2 any longer. So this is where I like to say, this kind of shortens it up. But, the physical meaning of this is that less than or equal to, that mu is less than or equal to or greater than 5.2. Okay. And keep in mind that this notation is going to tell us the type of test. We're going to see that just in a minute. And I could have a left-tailed, a right-tailed, talk about that shortly, or a two-tailed. And this is two tails. Okay, so that's why I like this notation more so. It kind of handles out the alternate test a little bit better. Okay, so here is just this very same things that I just went through: state an appropriate null and alternate hypothesis, write the statement, what they're trying to prove or disprove, write the complement, then do a H0 HA assignment, and then you're on your way. And then we'll see you next time. Hope this helps.